So again, we're on page 5 of 2.4 notes. Page 5 of 2.4 notes. So there are mistakes. We have to correct them. This first one, we essentially will have to redo the whole thing. But the second one, we could just kind of edit it. But for our first part, they said they distributed. Did they distribute?
Yes.
Yes, but not correctly, right? What part did they not do correctly?
They didn't.
Yeah, they did 5 times 3x, which is 15x, but they did not do 5 times negative 20. So essentially, we're going to have to start over. We're going to distribute ourselves. So 5 times 3x is 15x. What is 5 times negative 20? Negative 100 equals negative 10. This is the distributive property. Right there. So you can write distrib prop. All right, what do we do next? Add 100. So what property is that? Addition. Property of equality. So you can put add prop of EQ. So then we have 15x equals, what is 100 minus 10? 90. All right, and then my next step, divide by 15. So this is the division property of equality. So then x equals 6. I know if you look over here, I put substitution. Technically, 6 could be substituted for x, but we are not going to have to write that this year. So you can go ahead and cross it out. The only time I want you to write substitution property is if you substitute it back in for x. So this next one, what did they do first? Distributive. So they didn't write it down, so we're going to write it. You can shorten it to distrib prop. But it is the distributive property. We aren't going to need this box over here, just so you know. All right, and then they added 2x on both sides and wrote subtraction property of equality. So one of them is right and one of them is wrong. Should they have added 2x on both sides, or should they have subtracted 2x on both sides? They should have added. So the adding was correct. This cancels out the 2x. However, using the word subtraction property of equality was wrong. So we're just going to fix that to add, or you can write addition. But it is instead the addition property. So then they got down to here. We got 22x minus 36 equals negative 14. They subtracted 36 on both sides and then wrote add prop of EQ. So which one should we be doing? We should be adding to get rid of that 36. All right, so then what is minus 14 plus 36?
22.
It is 22. Let's go ahead and correct that. 50 should not be a 50. It should be a 22. Then if you just want to cross out everything that's under it, x equals 1. Questions about either of these two? Okay. Flip to the back. You're going to write down these two problems. And we're going to practice. We're solving for a different letter in like a formula. And then we're going to justify each step. So you want to write down both of them. We have Q equals C plus D over 2. And then we have 2x plus 3y equals negative 12. So what do we want to do first in our problem here? We want to multiply times 2, correct. So multiply times 2. This is called the multiplication, or you can write multiplication property of equality. This will cancel out the fraction on the right, and we'll have 2q equals C plus D. And then what do we want to do next?
Divide by 2.
What's our goal?
Oh, solve for
Get
C.
C by itself, yeah. So what do we
Subtract D.
subtract D? So don't write sub, make sure you write subtract. Because there are two sub-properties. Subtraction, property of equality. This cancels letter D out on the right. Can I subtract the letter D from the letter Q? Cannot, so I'm just going to write them next to each other. 2Q minus D equals C. You can leave it like this, or you can flip it. You can put it in the bin. Or you can flip it. We are going to flip it just to practice this property. What is the property called when you flip it like that?
Symmetric.
Symmetric. So again, you don't have to do the symmetric property, but if you do it, you do need to list it as one of your steps. All right, the second problem we want to solve for y. What do we want to do first to solve for y? Subtract 2x. Hopefully you have more room in your paper. This is the subtraction property of equality. Can I subtract a letter from a number? I cannot. So I'm just going to write them next to each other. 3y equals, do you want the x first or 12? X, okay. So minus 2x minus 12. And then my last step, divide by 3. I would divide each of them individually by 3 so we can reduce. This is the division property of equality. Sorry, it's kind of shoved in the corner over there. Division property of equality. So then we have y equals negative 2x over 3. And then what is negative 12 divided by 3? Negative 4. I can't combine anything else. I can't reduce anymore. This is just the answer. Questions on either of these? Okay. You can go to 2.6 notes. So, this first one is a theorem. We just have to say out loud. It's called the right angles congruence theorem. And it is that all right angles are congruent. So that is the first blank. All right angles are congruent. All right angles are congruent. What does congruent mean? Same measurement. So all right angles are 90 degrees. Okay, so here in this picture, angle 1 is congruent to angle 2. You don't have it drawn on your page because it's pretty simple. That all right angles are 90, so therefore they're all congruent. The second thing you're going to write down is if two angles are supplementary to the same angle. So if two angles are supplementary to the same angle, then they are congruent. And we're going to throw in numbers so this makes more sense. But if two angles are supplementary to the same angle, then they are congruent. If two angles are supplementary to the same angle, then they are congruent. So in this picture in particular, if angle 1 and angle 2 are supplementary, and angle 2 and angle 3 are supplementary, that means that angle 1 is congruent to angle 3. And I'll show you how this works. This is actually a little bit of the transitive property. So angle 2 was supplementary to both of them. So we're going to pick a measurement for angle 2. What does this look like it measures? That sounds good. 160. So to start, angle 1 and angle 2 are supplementary. So if they are supplementary, what does the measure of angle 1 have to be? 20. Separately, angle 2 and angle 3 are also supplementary. So what does angle 3 have to be? These two are supplementary. It also has to be 20 degrees. So because 1 and 3 are supplementary to the same angle, they have to be the same measure. Because there's only one way for two angles to add up to 180. I would have filled it in with the numbers, the 20s and the 160, just to kind of show you where this went. This is also true for complementary angles. If two angles are complementary to the same angle, if two angles are complementary to the same angle, then the two angles are congruent. If two angles are complementary to the same angle, then the two angles are congruent. So if angle 4 plus angle 5 is 90, and angle 5 plus angle 6 is 90, that means angle 4 and angle 6 are the same angle. So we're going to do the same thing. Let's pick a measure of angle 5. What do we think?
45.
See, everyone tries to pick 45, but then it gets confusing, because then all of them would be 45. How about we go up or down? 35, sounds good. So if angle 5 were 35 degrees, okay, and we know that these two, 4 and 5, add up to 90. What's the measure of angle 4 got to be?
55.
I think it'd be 55, because you'd carry the 1. And then if 5 and 6 were complementary, what does angle 6 have to be? 55, because there's only one way for 35 to be complementary with another angle. Do you have any questions over these two properties? Okay. Now on to like the main purpose of our lesson. We're going to be talking about linear pairs and vertical angles. Okay, so starting with a linear pair. The measure of a linear pair is what's going to go in the blank. Linear pairs are supplementary. Go and fill it in, and then I would highlight it. Linear pairs are supplementary. Linear pairs are supplementary. Linear pairs are supplementary. And then you've got like this picture down here. Should look familiar. I believe you had one like this on your test. Let's say that angle 3 was 10 degrees. All right. Where are supplementary or linear pairs? Where are they located? Like in reference to each other. So in this picture, what are some linear pairs we have?
2 and 3.
Angle 2 and angle 3 are a linear pair. Which ones? Angle 1 and angle 4. What else is a linear pair? Angle 1 and angle 2. And then angle 3 and angle 4. So they're located next to each other. 2 and 3 are a linear pair. 3 and 4 are a linear pair. 4 and 1 are a linear pair, and so on and so forth. So linear pairs are supplementary. So if they're supplementary, what do I do to find the measure of angle 2?
Subtract it.
Subtract it from 180. So what is 180 minus the 10 degrees we already have? 170. So then what does angle 1 have to be if 2 is also a linear pair with angle 1? 10. And then 4 has to be 170. Okay, these are all of the linear pairs. So if they're next to each other in this kind of picture, they add up to 180. But if they're across from each other, what kind of angles are they going to be? Vertical. And vertical angles are congruent. So that's what you're going to put in that blank and then highlight it. Vertical angles are congruent. They are congruent. Then you want two colors because we're going to highlight them in our picture. This one's much easier to highlight. There's only two sets. So vertical angles are congruent. The first set would be angle 1 and angle 3. So you highlight angle 1 and angle 3. And then your second set are 2 and 4. Angle 1 and angle 3, angle 2, and angle 4. So here's what you're going to do if you have vertical angles. I'm going to give you like a little cheat sheet here. If you have a linear pair, they're supplementary, which is what we just said. So if they're supplementary, what is the very definition of supplementary? They add up to 180, right? So you're going to take the two angles, they add up, and they equal 180 degrees. If you have vertical angles, what do we know about vertical angles? They are congruent. So you're actually going to take the angles and set them equal to each other. So in this section, if you have a linear pair, they add up to 180. If you have vertical angles, then they equal each other. They're the same measure. So that's what we're going to kind of be asking ourselves here in a second. We're going to practice first. This is on page 2. We have one angle measure. We're going to find the rest. We know angle 3, so we're going to find the measure of angle 1, the measure of angle 2, and the measure of angle 4. Go ahead and list them out, because that's what we're going to be looking for. The measure of angle 1, the measure of angle 2, and the measure of angle 4. If angle 3 is 128 degrees, what angle do we automatically know? Angle 1. What's angle 1 going to be? 128, because what relationship do they have? They're vertical, which means they're congruent. All right, and then what would I do to find the measure of angle 2? Subtract from 180. 180 minus 128, which makes? It's okay, 52. Which means angle 4 is 52 degrees. I do ask that you list it out like this. Some people have a hot mess in the middle of the picture. So listing it is just boom, boom, boom. Questions about this one? Okay. Next example. Find the value of x. Before you start, you want to ask, what relationship do these two angles have? They are vertical. So we're going to go ahead and write it. Because we're practicing. We have vertical angles. What do we know about vertical angles? They are congruent. So we're going to take one angle and set it equal to the other angle because they are equal in measure. So if TPS is 148, QPR equals 148. They equal each other. They measure the same thing. So 3x plus 1 equals 148. It doesn't matter if you had said 148 equals 3x plus 1. It's the same thing. The angles equal. It's the same equation that you would have set up. What is my first step to solving? Subtract 1. 3x equals 147. Divide by 3. You're struggling today. Oh, I see you have the answer. So x equals 49. What is a way I could check my answer? I could plug it in. And what should that angle equal? 148 degrees. So if you have vertical angles, that's a bummer. If you have vertical angles, they equal each other. All right, we're going to skip the bottom section for now and go back to it tomorrow as a review. We're going to move on to this question. So we have to ask ourselves, what relationship do these two angles have? They are supplementary because they're a linear pair. They're a linear pair, which means they're supplementary. Supplementary means we're going to add them, set them equal to 180. I keep writing this so that you can look back at your notes and figure out what you did and why you did it. We're about to add them and set them equal to 180 because they are a linear pair. So we got 6x plus 19 plus x equals 180. Combine some like terms, we have 6x and x, which makes 7x plus 19 equals 180. Subtract 19. 7x equals 161, yeah. Divide by 7. X equals? Correct. Right now it just says solve for x. But if it said find the angles, you would plug it in. So, but here it just says x. Questions about this one? Sorry. You can flip to the back. We're going to draw some really quick. You're going to draw these. We're not going to solve them at the moment. What we are going to do is set up the problem. Because I have faith in your algebra skills. We just need to know how to set up our problem. So go ahead and draw both. You got two straight lines going through each other. Some x's and some y's. So you'll draw both, and then we're gonna highlight some things. Is your hand raised?
Yeah.
Okay. There are two. All right, you ready? So the main question is, what relationship, do we have going on here? You would want to solve for x, and you'd want to solve for y. There's a very simple way to do it and a very complicated way to do it, and I believe that we all are for being simple. Is it easy to solve an equation that has both an x and a y? No, you won't actually solve for a number. So we want to get an equation that only has x's and an equation that only has y's. So you want to locate where, we'll start with x's, locate where they are. You got this angle, and you have this angle. They contain x's. What relationship do these two angles have? Yes, why are they congruent? They're vertical. So in this first picture, we have vertical angles, which means that they are going to be congruent. We are not going to solve, we're just going to set it up. This means we would have 5x minus 20 equals 2x plus 25. So again, we're not going to solve, we're just setting it up. As for the y's, they are, of course, located across from each other, which means, again, they're vertical. They would equal 4y plus 69 equals 3y plus 83. Okay, and then you would solve accordingly. In the second one, it's a little different because we have an x and we have an x. Are they located across from each other? They are next to each other. So these are not vertical. What relationship will they have? They're a linear pair, which means they are supplementary. They add up to 180. So in this second problem, it would be different. We would say 3x plus 72 plus 4x plus 31 equals 180. And then you would do the same thing for the y's, because they are also a linear pair. 6y plus 9 plus 7y plus 28 equals 180. Do you have any questions on the difference or why, or did I write something down wrong? Why?